Hi friends, welcome to another video. But this video is not for students. This is strictly for educators or college students who is interested in learning FPGA. So this video series is a pure gold. If you know Shawn Hymel, he is one of the renowned person in this field, and he has this whole tutorial of FPGA, and he is covering a FPGA which is open source FPGA. You can download, somebody can create a board out of it and sell it, and you can write Verilog code, or you can write drag and drop code using iStudio IT. So this person, Shawn Hymel, he has focused in this video on writing code in bare hand. Writing raw code of Verilog. So if you want to follow his video and try to learn along with all the exercises he's asking to complete, then you need that FPGA board in your hand. So what is the FPGA board he is using? So this is the FPGA board he is using. So I'm just being too lazy, I just asked Gemini what is the board he's using, and then this is the one. And if you are in India, I don't know the other part of the country, but if you're in India, the cost of this board, if you want to buy to follow this video, it will come around 14,000 rupees, or maximum 22.4 including GST. So yeah, so this is a bit costly if you are a student or just a enthusiast like me. So what can be done? So what are the cheapest board available? And then I see the options like there is one Sipet Tang, but I see it is out of stock in Rogu right now. But the point is, this may not work with all the terminal commands. So then what is the next option they are saying? The next option is of price 7.6k from Fab2Lab. So it's a trusted website. I have purchased a couple of things from this website. So it's good. But what can be cheaper than this? So I know a person personally, Mr. Hardik. He is also in this. He is one of the designer of this kind of devices. So because this Lattice Ice 40 is a open source hardware FPGA board, so anybody can create their own, and he is one of them who has already created such. This is his LinkedIn profile, and he has created this board called SoanPapdi, you can say made in India, and this cost 5,000 rupees right now today when I'm recording the video. So if you order from him, so you're getting in 5,000. This is not a paid promotion, but yeah, really I love his work, and please feel free to write down if you know any other cheaper FPGA alternate, and definitely I would encourage to buy and encourage this person, this our Hardik bhai. He is the creator of SoanPapdi, and in this video, because I have a SoanPapdi board I purchased from him. It's not free, it's I purchased from him. So if you want to go with this, when you are following through this video, then I would go through how to install all the things and prepare your computer to start with the SoanPapdi board, and then follow along with the instruction by Shawn Hymel. So the main agenda of this video is, if you are a FPGA enthusiast or want to learn FPGA for as a hobby or for your educational reason or for job or anything, this is a pure gem. And if you want to follow across, you need a hardware, FPGA hardware, and this is a video where I will show you how to configure your computer with this SoanPapdi board so that you can use it, and it is from scratch, not using the iStudio software. So I will show you what is the iStudio software. First of all, if you download iStudio, they have a iStudio support as well. So if you download the iStudio, and if you open it, you will see a graphical way of joining all the circuits. So if you know what is FPGA, I will not explain this in the video. So if you know how, like, there will be input and output, and there will be many lookup tables and all things. So this is the pictorial way of connecting from input to output, and this is actually I'm not doing anything, just you press the button A0 and then you get the D0 light LED glowing. So this is the board where you see a couple of switches in the below red color, and there are the LEDs of I mean, what is the color? Red LED or orange LED. So, and then they have some configurable pins also where you can connect your sensors. So this is a minimal thing for very beginners. It is very helpful because it has a jumpers connection and all this button already set. You don't have to do all this jumper cable connection and all. So this is the UI, but without installing the software in the iStudio way. If you want to install this iStudio way to explain to kids, you are most welcome. They have a post in this thing Hackster.io. So Hackster.io, they have a, I think this is the one, yeah. So they have a getting started. So step by step you can follow and you can install the iStudio and be done with it. It's a graphical way and very entertaining for even students and like 8 years, 9 years students also. But for now, we'll concentrate on our educators. Okay, so how we can do that. So for that, first of all, I will open a fresh folder. I'll go to my C drive and create a new folder. So I have this one public, but let me create a new folder called temp. You can give a better name because I'm going to delete this after the video. I have already something. So this is the folder where I'm going to create a virtual environment. So you need Python. So I'm not showing you how to install Python. You can download Python 3.xx. anything more than 3.12 is better. And once you install, you have to set the Python exe path into your environment variable. So these are the things you have to do. I'm not covering it here. You can follow some other video how to set up your Python path. So you can give the direct path into path variable either in the user variable or in the system variable. One of those path list, there could be one of them as the Python exe path. Once you do that, how to know that Python is accessible from anywhere in your computer? You just open the command prompt from anywhere and write Python -- version, enter, and you see the Python version is mentioned. And if you want to know where it is, where Python, you say where Python, it will tell you where it is currently referring from. So you don't need to know that because you already see just Python and you are getting it. It's good. But if you somehow not able to figure out where the environment variable to be set and all, you can directly copy this Python and directly refer. But that's not very convenient way, I would say. If you do this and say -- version, that too will work. But every time referring to this long path is not practical. And yeah, there are multiple complications. So let's not do that. We'll install means you install it in environment variable. How to do that, details you can see in other video. So given that you have the Python install and you can query it from anywhere in your computer, I will proceed to the next step where I want to create a virtual environment so that you what you can do, you can actually install all the packages that you need for your FPGA board connection directly into the Python's own library, but that is not maintainable or it's not a good way of doing. Better to capsule them or sandbox them in a folder where you can anytime you can delete or anytime you can transfer to somebody, copy to somebody. You can you have the full flexibility. It's an isolated folder where you have everything that goes along with each other. I mean, you don't have to you will not have any external dependency. Everything is inside the folder. So that's the best way of developing any Python thing, right? So that's what we're doing. For that, there's a command. I have already listed out the command for this video. So this is the command for that. python -m, anyway you have to write this, and then venv is the command, virtual environment, and you have to write the folder name. So you can write any name here, whatever you are comfortable. I'm just writing FPGA venv. I can even write SoanPapdi venv or anything, your name also. So just press enter and you see a folder gets generated. So once the folder gets generated, you will see some basic minimum thing will be there, and under script you will have python. So it's still generating activate.bat. So this activate.bat is the one who will have all the environment variable or anything that you need, like anything that you I mean, this is the batch file that will bring the sandbox open to you, so you can install anything, you can uninstall or whatever you do, it starts from there. Once you open that, activate that batch file, you are in the sandbox. So that's what. So given that you can activate that way, how so let's see how we can activate. So we can directly go inside this. So cd and then script. Let's see. Well, scripts. Oh, so FPGA venv, cd FPGA venv. So if you press tab, it will auto complete your sentence. cd script sc tab scripts, and then I want to see what is inside dir, and activate.bat is there. So I'll just have to say activate. It will find out what is that and what to do. So ACTI activate. Okay. Once you say activate and it executes the batch file, or in PowerShell activate.ps1, whatever it is, and then you see this kind of prompt. So you see FPGA env. So you're already in the virtual environment, you're already inside it, and now whatever you do will be impacting this one. So if you install something, for example in this mode, python install something, once you come out of the venv and you are in this level and asking for what are the software, I mean what are the package you have already installed, you will not see that in your list because it is inside the virtual machine. So anytime you activate, you get those, otherwise no. So okay, now what we'll do, we will install a software, I mean a package called APIO. So APIO is a package that encapsulates all the necessary APIs that you need to program FPGA or to decode your Verilog code into a machine understandable or FPGA understandable code. So anything that you need, compiler or the how to flush to the FPGA, everything is packaged into APIO. So APIO later will install all the dependency and finally it will be all in one. So APIO package install, this is the first command. What happened? So APIO package is not working because I haven't started with Python. I have to install APIO first. So pip install first. Yeah, so APIO is not there. I cannot just call it. So first I have to use the pip Python pip and install the APIO, and then I can call the APIO. So this will take some time. Yeah, so it's done. Now next we will ask him to install all the packages. You see so many things it has internally installed, and we will run this and see what else is being installed, like YOSYS, YOSYS, and some other APIs are needed in order to use FPGA. Now API package installed. Let's see. And this will also ensure if any new board is available, it will. Oh, my antivirus. This is another thing you have to remember. If you have Avast, definitely disable the Avast antivirus. It's disturbing me left and right for anything. So I will disable it for 5 hours. Yeah, so I'll disable it for 5 hours, and then let me finish everything and then let him come back. Okay, so this is, I believe this is just to flush the check if any update is there, but the main installation has already been done, where UOCs and other important file that is needed for packages that is needed for the FPGA coding is already being installed in the first command itself. And now what we will do, okay, so we'll see some commands that is working, I mean to see APIO is working and everything is copied properly. So I'll say APIO and info system is one command that will tell some information that you may not understand right now, but just to see the data is coming to ensure that APIO is installed properly. And then you want to see APIO drivers. So this will, what happened? APIO drivers install. No, not this, sorry. APIO boards. So I already have the driver that I'm looking for. So let's see if the board is already there, the SoanPapdi board. If not, then we have to do this. But because SoanPapdi board doesn't need any FTDI, it doesn't have any FTDI chip in it. So automatically USB will, our Windows will detect the SoanPapdi board without installing any driver. So just enter and you see 83 boards, actually 82 boards are there, and I was experimenting something, so one extra board I added. So this SoanPapdi, you see it's already registered, and you will, once you install the APIO, you will see SoanPapdi is there because they have registered. I was trying with Rasgulla because Hardik ji made SoanPapdi. I was thinking if I can run the same by Rasgulla, but yeah, you can try personally, but this is not recommended. Okay, so with this we are now ready, and our APIO package is already installed. So now we will try to create a hello world kind of code in SoanPapdi. So what we'll do, we'll just create a code that will, once you press a button, a light will glow. Just simple like that. We'll not even go with blink because the blink involves clock pulse, and FPGA has its own internal clock and you have to refer that will complicate a bit. So I would say that is not the hello world in FPGA. The hello world I would recommend as the press a button and the light will glow. That's the hello world. Okay, so for that, how to start? For that, what we'll do is we'll create a folder. Don't create anything inside the venv virtual folder, leave it. Just create another folder called project. Inside the project folder, you create your project folder. So project 1, you just say hello world or blink, maybe not blink, sorry, the press button, that whatever I say. So now from okay, so we are done with that command prompt, so I can close this. Our virtual environment is ready. Once I close, whatever I activated, actually you should deactivate it, but it's okay if you just activate and you just close it, it's gone. So now I will open a command prompt in this folder so that we can start with our development. So there is an easy way of creating opening a command prompt here. Just go to the address bar, type cmd and enter. You get a command window in that tab. Now to run that same activate batch file, how much we have to go back? 1 step, 2 step, go back, and then go inside, and you have the activate.bat, right? So to do this all in one shot, how we can do is, so you have to go 2 step back, dot and slash dot slash, even 2 step back, and then followed by FPGA venv, and then script, and then activate. So this much, if I copy and paste after this, this is the path. So if you can copy it somewhere, and every time you go to a folder in that level, you just press enter. Once you press enter, you are already into the virtual environment. You have everything available to you, like APIO boards. If you type, you will see all the boards available to you. So you are right now in which folder? You are right now in project hello world folder, and from here you have activated the virtual environment. Now what next? Next you have to create the ini file. Okay, so there are 3 files you have to create in order to run FPGA. So everything, this and all, you can get from Shawn Hymel. I will not go in details, just showing you that how SoanPapdi board will work. So I will just paste. This is the command APIO create minus minus board, and then SoanPapdi all in small letter, and then you press enter, and it will create the ini file for you, APIO ini. So if you open this, so this is how it looks like. You have a SoanPapdi board, and yeah, this is what it generates. Now we need 2 more files to generate. For that, I will just copy it from one of my code, and that is in my SoanPapdi sample code button on. So this one I want to do. I'll just explain you, and don't worry, because it is not a Shawn Hymel has already explained, so I will not go into that details. But definitely for the sake of SoanPapdi, how it works, I will explain it. Let me see. Okay, yeah, here. Not here, sorry. I'm in project hello world, and this is already there, so I will just copy 2 of the file, not all the file. So this we already have, main.v and PCA. These are the 2 file unit code. That is the program, main program, and this is the pin diagram or the pin that you are going to use. So these 2 alone I'll bring out here, and I'll delete everything else. And what it contains? So Pinout will contain the pin structure or the Pinout diagram of SoanPapdi board. And remember, this is different. So Shawn Hymel will tell a different pin diagram, and but SoanPapdi it will be different. So this alone, I would say, will be different from what Shawn Hymel will tell in his video. So how much different? What are the different value SoanPapdi board has? How to know? So for that there is a hack, but I am not going to the details of hack. But I would give you after hacking, means after that finding, what are the pin numbers I already have. So I'll just open it. So this is the pin diagram, a pin number. I will share this in my Google Drive. So any of this pin you want to use, you can use this. So yeah, basically I can explain you how I found it. Actually there should be a better way of doing this. Mine may not be the best one, because the map should be already available into the iCEstudio. In the iCEstudio it should be already available. So what I did, the project you saw right at the beginning, that project I have mapped all the pins so that it generates a mapping file with all the pins in it. And then when it generated, like input, and then I1, and then from here I select A1, and then output O1, and then connect D0. Now we connect this two. So similarly I created all the pins whatever it's having, and then I open it and save it as, say, test was there, and then just for now I will show you test2, and this 2 file got saved in a path. I will open the path now, because iCEstudio has all the map details of SoanPapdi. I'm just taking it out of it. So SoanPapdi, and then what is, where did I save? Save as, of FPGA. Okay, so if I go to the FPGA folder, this is a test tool just now we created. This ICE file is actually XML file. You can open it, and when you open it, you see the connection you made, right? There you will get A0 is actually 6 and then D0 is 31. So these are the numbers I made a note. So I connected all the pins so that I get a complete pin details. Not all the pin, but at least the buttons and LEDs, whatever they had. And I got this file where A0 is 6, then D0 is 31, A1 is 4. So these are the numbers you need to remember for to use the SoanPapdi, and that is the list I showed you here. So this is how I got. So if you need any more, because it has many other pins, you see this IO 1 2 3 4, these are the pins you see, which is the jumper cable. You can put the jumper cable, and this is the open pins, and they are named like that. They can be used as input or output, any output. So those are the pins. So you can also connect them and save it and find out what is the IO4 pin number. So once you have all the list, you have this, and then we'll go back to our project. We'll go back to our project and continue from there. Then PJB, sorry, not the one. This one. Yeah. Okay. So this PCF correct. So how much ever you need, that many pins you can declare. So I just need one button and one LED out of that whole list. So D0 31 and A0 6. So these two alone I took from that, and that's all about the pin configuration file for this project. And then finally the main code, main.v. So here you have to declare, so I'll not go into the details of how the Verilog code to be written, but here this is the important line. If you know, D0 equal to A0, where you switch on and off the button, and what is the button state, exact state he will get. So if he is on, then the LED will be on, and if you want to reverse it, you just make it inverse. So if it is on, it will be off. And okay, so this is I'm okay with this. So this is the simple code, and that's why I say it's the best hello world code here. Now coming back to the code, and then what next? So if you have already compiled and there is some change, so better to do APIO clean. So already clean, so it's nothing to clean actually now. APIO build. So once you do build, success. So this is good. Now to program this board, what you have to do is you have to press one of the button, and then don't leave it, just press this button and leave it. You see a light glowing, and then leave this button. So now this is in programming mode. I'm just showing it quickly because anyway you can see in their documentation or their video they have explained it well, but if you don't do that, your code will not upload. So APIO upload. So if you do APIO upload, so this will be uploaded given that you do this step. So now if I press enter, it's uploading, and success. So now it's uploaded, but still it's not up and running. For that you have to press the reset button once. This is the reset button. I press once, and then where is the A0? So there is a marking, and I know this is the A0, and now I'll show you. So this is the this is the A0. I'll just face towards you, and then I will operate this. So this is the A0. I'll just switch it on, and see the light is glowing. Off. On, off, on, off. So our code has flushed successfully, and without using any IDE, we have uploaded the raw code, and that's where the Shawn Hymel was explaining how the different things can happen. And then he will explain the clock, how to implement the clock, I mean the blink and other things, different kind of clock pulses and all. So for that I was preparing this one more project. Okay, so this is the project I made. I'm going to delete this, but what I have already with me, this is the progressive blinker where you can see another code, courtesy Gemini. I'm also learning. So this is the code for progressive blinking. So you see multiple arrays, and in the PCF file you have to declare an array of pins, because then only you can do this kind of thing. So you have declared the registry 28 bit, and then the counter is increasing, and as you know, if the counter adds one, that bit will shift from left to right, and if you follow which bit, and based on that you can decide which pin will blink at which speed. So in the output of this code is one of the LED will blink at 1 Hz, second immediate next LED will blink at 2 Hz, and multiplied by 2. I mean the binary 2 to the power formula. Okay. So this is what I start. So yeah, you can keep trying all the different things, because you see clock is already considered here, and clock is not a pinout. It is because the ICE40 model, that the FPGA model they are using, and all these are ICE40 class. I mean ICE40 I mean series of FPGA everybody is using. So definitely these internal things will not change its pin. Only the pin that we use for outside, I mean the output pin, that are the things going to change, and we have to take care. But the internal clock and how many LUTs are there, or how many D flip-flops are there, and then all these internal details is going to be same, because they are the same ICE40 chip. Okay. So I think that's what I wanted to say, so that you can proceed with this, and you can just place the order to him if you want, and definitely let me know if there is any cheaper FPGA board, and if you want to order or promote, or I mean to encourage Mr. Hardik, I can help you to get his contact number, or you can directly go to his Pyajama Cafe or Hardik. So Hardik SoanPapdi. So he's the guy, Hardik said. So
This is Soan.
So Hardik said he is the person, and then you can directly order him, or let me know in comment. I can help you to get you in touch with him. Or anyway, you have the Pyajama Cafe. Pyajama Cafe. So here you can get the tutorials. They have a good community support, and they're explaining how to use it and different thing, and in upcoming videos also will be there. SoanPapdi FPGA, so you have all the stuff here, and even the Hackster IO is there. So yeah, please encourage these new startups and people, so that we all get benefited. And especially I love his work, because he's trying to make it very close to the students, kids who cannot imagine they can use FPGA board in their in this age, like 8 years old or this thing. He's trying to bring this to their level. Like suppose this one, I will just end with this. So you have this toolchain, I mean the toolbox, where you can get without writing all this code, you can just go and take a AND block, and then connect to input I1 and I2, A0 and A1, and then just delete this, and then connect like this. See, it's so easy. You don't have to write the, I mean your students don't have to write the code for us. We have to learn it in the hard way, but for students this is so easy. people can't imagine maybe like few years before that even FPGA can be this much simple using iStudio. So there are many other boards that has bring this same simplicity to the people, but he is one of them, I would say. But if we promote him, if we help promoting this iStudio, which is a free software, to people, maybe we can see our students, our son, our relatives, they started using FPGA where other people are just using the Arduino microcontroller. People on that age using FPGA board is really surprising. So yeah, that's what I want to say. So if you just plus the code and it will start, it will expand. I mean, it will go there. You just have to click on this upload button. But before that, you have to do that ritual again. This one, click it, and then press this button. Oh, what happened? Oh, this was blank. So A0, A1, and A1. So now plus, and it's done. Now I have to reset once, and then A0 and A1, right? So A0 and A1. I'll show you like this. AND gate. So 1 0 will not work. Only 1 1 will work. Is it working? A0 A1. A0 A1. Oh, IO4. Sorry. This is not the LED pin. D0 to D0 to D7 is the LED pin. So that was like one of the jumper pin where you have to connect the LED to see the output. Better not to do that. Oh, this is because I haven't done that set. Wrong place. So this is program mode. If you miss, then you will get this message. And now upload done. Now you see. I just reset, and then you see right out of the box it is glowing because I left both of them on, A0 and A1. So I just stop one of them and it is off. Any one of them if I stop, it will be off because AND logic. Both have to be on, then only it is on. Yeah. So yeah. So the main point is you can also learn, and your students and friends and everybody will be benefited. Yeah. And then with that, I want to say goodbye. Please write down in the comment if you have any other suggestions. Thank you.